Okay, the the coil turns are very thick. This is a gorge type coil turns. This is very thick. This is different and very different from a helix, which has layers of coil wires that are overlaid with each other right on top of one another, like a stair. So when bending, when making a helix of a coil as far as a voice core, it's different to where they're corresponding one on top of one another, exactly parallel on top of one another. I think you can see it with this camera. But this is the gauge. I have a 10 gauge wire, which is a group wire, which is considered a 10 gauge wire. This is the gauge of this coil. These represents the single phase of the gauge of the coil. So this gauge exceeds past 1. Whereas the voltage over 19 gauge of copper wire is infinite in voltage. Now this being more greater than number 1 gauge as of the thickness of the group of the wire. These are group coils, so it's a grouped wire or group coil, to where the electromagnetic frequency as far as the vector is broad, and as the wavelength is in distance more wider and broader. So therefore it's greater than. This can take upon gigajoules. Now, as of the length, see, I'm not even halfway through it, and it's way over more than 1,000 turns of gauge of 24 gauge copper wire. And I still have an open clearance. I left this part open right here so I could place the coils going up in sets like a linear motor, starting from the foot here all the way up to the top. It's a long way up. Okay, now the winding turns and the coils that are here are greater than the coils that are in this motor. It's going to be very hard to hold this motor. This has a freedom ball bearing within the shaft, which is only localized by 1 millimeter local to a commuter that sends the electromagnetic energy. Thus, this is a brush motor that has brush that's paneled close to the panels that causes the induction of the current. So, being phased 2 ways in a DC motor. Now, this has a high torque because it's locally near and it's touching, so it's DC, and it has a wild torque to it, so it's hard to stop it with one's manual hands. Therefore, the strength and the kinetic energy, the Newton force is greater than my physical force. However, this may not be that strong enough to withstand my entire body or weight, mass on it, but it might be. Who knows? I know it's very strong, hard to grip. It's powered by AC. This is an AC brush motor. Now this is a wheelchair motor. I don't know if you can see it down here. This is a wheelchair motor. And this motor right here, see that motor right here? It has less turns in this coil in this motor, but it is synchronized as a synchronous motor. And it's not a brush motor, it's a synchronous motor. And it has coils. It has permanent magnets, which are ceramic magnets, not nickel-neodymium, but ceramic magnets localized on the side of the armature. And this is torqued in the central. This is a permanent magnet motor, and it moves this gearbox to move this entire machine, which is actually a wheelchair. And this can lift about and move about 1,100 pounds. This motor gearbox is 1,100 pounds. And the turns in this coil is what's giving it the power in order to crank and rotate the rotor, which is the armature. However, the coil turns are less than this. And this is able to move 2 human beings on a wheelchair. This turns are greater than. However, it is incomplete, where the other turns will have to continue to the top, which means that this will probably be more stronger than 4 wheelchairs put together. 4 wheelchairs torque, which has this as 1,100, and I believe this is 1,100 and about 385 pounds torque energies. This torque energy is greater. Now the gate that I'm applying onto it, the aluminum gate that I'm applying onto it to move it, to actuate it, to cause it to lift, while the aluminum fixed on the bottom will cause the coil to escape from it with great exceeding force. However, it will be binded to the side of it, so it does not cause it to escape. However, it keeps moving in linear motion upward. Turns. I got up to this part, so I'm going to continue tomorrow and finish the rest of the coils. And not only am I going to do that and wind it all the way up, but I'm also going to do it again, separately. It makes sectional sides like a transformer. Watch when you see the outcome of this. But however, you will not see me wear this unless the repulsor stabilizers are made. When I make the stabilizer similar to the same matter, that is the only way. I'm not going to break my neck like Iron Man did. What? Flying engineer. Okay, so my name is Jermaine Morton, and goodbye. I see you later.